Okay, in the previous video, we had seen what is the positive and maximum positive and negative shear forces. The same problem we are now going to do for finding out maximum uh, bending moment. Okay, maximum bending moment and shear force at a section. So I'll just draw the figure again. So you have a simply supported beam, and this is section C. Let this be A and B, and we have the section at 8 meters. Then it's a 30-meter span beam. Okay, you have 4 point loads, each spaced at 2 meters. No? So with the 10 kilonewton load is leading. So 10, then 15, another 15, and then 8 kilonewton. Okay, so it is moving from left to right. This was our case. Now first, you already remember what is the you actually have to position this load in such a way that you get a maximum bending moment value exactly at this section C. Okay, so we don't know what is that position. So let us first find out the maximum ordinate for bending moment. In the influence line diagram, it was given by Z into L minus Z by L, which is equal to 8 into 30 minus 8 divided by 30. That is equal to 5.866 is what you will get. Okay. Now you have to find the load position for maximum moment. Okay. So we know that the average load on AC should be equal to average load on BC. And we also said that such a condition is practically, it is not possible because you cannot split a load and then make sure that the average load on AC is equal to average load on BC. So I told you at that time that you have to find a critical load. Our load, that load when it passes over section C, there is a change in the balance. Like AC might was heavier before, and then suddenly when this load jumped to the or cross section C, BC part became heavier. So you have to find that critical load. So we will write to find the position, of loads for maximum bending moment at section C. The average load on portions AC and BC is to be found out. Okay, so I'm going to make a table. First is load crossing, which load crosses section C. Then average load on AC. Okay, next average load on BC, and you can just make a column for remarks. Okay, so I'll do one thing. I'll call average load on AC as W1 and average load on BC as W2. Okay. Now first load is 10 kilonewton. Okay. All the loads are moving from left to right. Suddenly 10 kilonewton crosses. Average load on AC is you have to add 8 plus 15 plus 15 divided by 3. Not 3. Sorry. Divided by length of that section, which is 8 meters. Okay. So this gives you 4.75. Average load on BC is only 10 has crossed, so 10 divided by 22, which is equal to 0.45. So you can make out that W1 is greater than W2. The next load 15 kilonewton is crossing. So average load is 8 plus 15 by 8, which is equal to 2.875. Second is 15 plus 10 divided by 22 because 15 also has crossed there. So you will get 1.136. What is the inference? W1 is again greater than W2. Okay. What is the next load? Next load is the third 15 kilonewton crosses section C. Then average load on AC is only 8 divided by 8, which is equal to 1. Whereas here you get 10 plus 15 plus 15 divided by 22, which is equal to 15 twos are 30 plus 10 40 divided by 22, which is 1.818. So now you have a reversal. W1 is less than W2, which means this third 15 kilonewton load can be identified as the critical load. Means when that load crosses section C, you are getting a reverse, that is an unbalance, that is the BC gets heavier than AC. So we will take that critical 15 kilonewton as critical load, and we are going to place this load on section C for a condition of maximum bending moment. So we'll write here, hence 15 kilonewton load is the critical load, hence maximum bending moment will be obtained, okay, will be obtained at section C when this 15 kilonewton load is placed on section C. So I am going to place that load. So I'll go back to the diagram, and I'm going to use another color. So I'll place that 15 kilonewton load, third one, okay. Then after 2 meters, you have another 15. After 2 meters, you have the leading load 10. Then behind this, you have an 8 kilonewton also. So all these will have some ordinates here. Okay, let me draw the BMD. Not BMD, it's the influence line diagram for uh, moment. Okay, this looks like a curve. I'll just make it a straight line. Okay, now let's mark the ordinates. So for 8, you have an ordinate here. This is the critical ordinate for the critical load. Then for second 15 kilonewton load, and then you have a 10 kilonewton. So this is 2 meters, 2 meters, 2 meters. This you have already found out as YC. Okay, let this be Y1, then let this be Y2, and this be Y3. You have to find, we have done in the previous problem, you know how to find Y1, Y2, etc. YC you have already found. Okay, so YC is 5.866, you have found it out. Therefore, maximum bending moment is, from the figure, maximum bending moment at section C is equal to 8 times Y1 plus 15 into YC plus second 15 into Y2 plus 10 into Y3. So this is equal to 8 into 6 by 8 YC plus 15 into YC plus 15 into 20 by 22 YC plus 10 into 18 by 22 YC. Please check those values. I hope you know how to find those. So അതാണ് വീണ്ടും ചെയ്യട്ടെ. You will get this simplified 35.199 plus 87.999 plus 79.999 plus 47.999. So giving a total of 251.19 kilonewton meter. So this is the maximum bending moment at section C. Okay, I hope it's clear.